Welcome to the Intel Quartus Prime software Tcl Scripting online training. My name is Steve. Starting with version 15.1, the Quartus 2 software is now known as the Intel Quartus Prime software. There are three versions or editions of the Quartus Prime software: Lite, Standard, and Pro. The Lite edition is similar to the Quartus 2 Web edition. It can be downloaded and used without a license, but has limited device support and does not include all the features of the other editions. The Standard edition is similar to the Quartus 2 Subscription edition. It supports all device families up to the Intel Array 10 and all existing Quartus features and tools, but it requires a software license for use beyond an initial 30-day trial period. The Pro edition is new with the move to the Quartus Prime software. It includes a number of new features, including a new synthesis engine and enhanced tools for working with Intel's most advanced FPGA devices. Going forward, the Pro edition only supports Array 10 and newer devices. For detailed comparison for all of Intel's FPGA design software, click the link listed in the slide. While there, you can download the software. The purpose of this presentation is to introduce Tcl Scripting in the Intel Quartus Prime software. To get the most out of this presentation, you should have some knowledge of Tcl Scripting and some basic knowledge of the Intel Quartus Prime software and the FPGA design flow. Please consult our other online trainings in those areas if you're not familiar with those concepts yet. At the end of the presentation, you should be able to describe commonly used Quartus Prime software Tcl packages, create Tcl scripts to perform common tasks in the Quartus software, describe some useful commands, and be able to run your Tcl scripts with the Intel Quartus Prime software. This is the agenda for today's presentation. First, I'll talk about Tcl scripting support in the Intel Quartus Prime software. Then I'll go over 4 common uses for Tcl scripting in the Intel Quartus Prime software: creating projects, compiling them, accessing report data, and analyzing timing. Then we'll move on to miscellaneous useful Intel Quartus Prime software Tcl scripting commands, followed by accessing command line options, and lastly, we'll talk about using Tcl with the Intel Quartus Prime software. Let's start with general Tcl scripting support in the Intel Quartus Prime software. First, I'll talk about 3 main benefits of using scripting in the Intel Quartus Prime software. They are custom analysis, automation, and reproducibility. Custom analysis refers to extracting only the report information that you need. Intel Quartus Prime software Tcl commands make it easy to extract only the information you need. Automation means you'll be able to eliminate manual steps in the graphical user interface. For example, you can eliminate repetitive steps when making pin assignments. You can also interface the Intel Quartus Prime software with other EDA software in a complete end-to-end flow. Repeatability refers to easier project maintenance. You can put all the commands to create and compile a project and extract report data in a single script. This makes it easier to document and run. This will complement your regression testing methodology. The Intel Quartus Prime software provides extensive Tcl scripting support. Support ranges from basic commands for making settings and assignments to advanced commands to access internal data structures. Almost everything you can do in the GUI, you're also able to do through Tcl. Most command line executables in Intel Quartus Prime software include a complete Tcl interpreter and provide access to the Intel Quartus Prime software Tcl API. The Intel Quartus Prime software Tcl API includes hundreds of commands and over 20 packages. More detailed information about executables and packages will appear later in the presentation and in printed documentation on the Intel FPGA website. Tcl commands are grouped by function in Intel Quartus Prime software Tcl packages. In each command line executable that includes a Tcl interpreter, a subset of the available Tcl packages are preloaded. This reduces the memory footprint, but does mean you need to remember to load additional packages as necessary in your Tcl script. It is important to know that not all packages are available in all command line executables. The packages available in each executable align with the executable's functionality. For example, the Timing Analysis Tcl package STA is only available in the Timing Analyzer STA command line executable Quartus_STA. Here are some of the most commonly used packages in the Intel Quartus Prime software. These are the ones I'll focus on in this presentation. A list of all the packages available in the Intel Quartus Prime software is available in the Tcl Scripting chapter of the Intel Quartus Prime Pro Edition Scripting User Guide and the QHelp Utility. I'll provide more information on these references later in the presentation. Use commands in the project package to create projects and make assignments and settings. Use commands in the flow package to compile projects and run other common flows. Run commands in the report packages to create reports and extract information from the reports. Use the STA package to create timing information and run various time reports in the timing analyzer. If you need to, you can use the Quartus Prime software-specific load package command to easily load packages. The syntax is load_package, followed by an optional version number, and then the package name. Using the ::Quartus: is optional when you use the load package command. Alternately, you could use the Tcl command, package require, to load any of the packages, but the Quartus load package command makes it easy to load and unload different versions of the Intel Quartus Prime software packages. Now I'll introduce the first sample application of the Intel Quartus Prime software Tcl API, which is creating projects. The Quartus Project Tcl package include commands for creating and working with projects and revisions, and for creating and working with assignments and settings. The commands listed here are a subset of commands available in the project package. There are a number of commands for working with projects and revisions, including project new, project open, and project close commands. Use the create revision to create a new revision, which contains an alternate set of assignments for you to try on the current design. You use the set current revision to specify which of the multiple revisions in your project is going to be the current one. You can use assignment commands listed here to make both general assignment that applies to the entire project or design-specific assignments that apply to specific design nodes or entities. As an example, the set location assignment can be used to make pin assignments. Here's an example of a Tcl script that creates an Intel Quartus Prime software project and makes some assignments. This example uses the design files for the FirFilter design that's included with the Intel Quartus Prime software. First, the project new command creates a new project named FirFilter. Using the -revision option, specify the revision name to be filterref. The -overwrite switch overwrites any existing project files of the same name if they exist. The following set global assignment statements follow the syntax set global assignment -name, assignment name value. We assign the family, device, the name of the BDF and Verilog source files, and the top-level entity of the project with the global assignment commands. We also use the set global assignment command to point the project revision to an SDC file used to provide timing constraints to the project. Next, the script uses the set location assignment to assign the signal name clock to pin AH10, a global clock pin on the Intel Stratix 10 device. Depending on device support, you can also assign signals to I/O banks, locations, and edges of the device. Finally, the project close command commits all the assignments to the Intel Quartus Prime software settings file and closes the project. Now, the project has been created and assignments have been made. At this point, you can open the project in the Intel Quartus Prime software and compile it. It's important to be aware of how the Intel Quartus Prime software processes assignments. When you make an assignment in Tcl or in the GUI, the assignment is not immediately saved to the Intel Quartus Prime software settings file or QSF file. Because of this, it's possible for settings to get out of sync if you have the project open in multiple places or if you're editing the QSF in a text editor. Some actions, such as closing the project or running compiles, save any changed assignments to the QSF automatically. You can also use export assignments command to cause the Intel Quartus Prime software to write all assignments to the QSF at any time. Now, let's look at a case where you need to use the export assignments command, and then I'll tell you how to change your script to avoid the need for the command. The export assignment command is typically used before running Quartus executables through system calls. This example opens the project, sets the family to Stratix 10, and synthesizes the design. The set global assignment command does not write the assignment to the QSF file. So, when we run Quartus_syn through the system call's QExecute command, we are really opening a new instance of the project with the assignments in the QSF file without the new family assignment. Here, we must use the export assignments command to ensure the QSF has the new family assignment before calling the Quartus_syn executable. On the other hand, if we use the execute_module-tool syn command instead of using the QExecute system call, we don't need to export assignments because the execute module command will automatically commit settings to QSF. Now that we've talked about how to use Tcl to create projects and make assignments, let's talk about how to use Tcl to compile designs. The flow package includes commands to compile designs and run common flows. A flow runs a series of executables with various predefined options to perform common processing tasks. Compiling a design is a flow, as is performing I/O assignment analysis. Most of the items listed in the processing menu of the Intel Quartus Prime software GUI have corresponding flow or module names you will be able to run in Tcl. The execute_flow command runs one of the predefined flows. The execute_module command runs a module that is a command line executable. The execute_hc command starts one of the predefined hard copy flows. The flow package is not loaded by default in any command line executable, so you need to load it using the load_package command before running any of the commands in the package. Here's a simple example of how to use the flow package. The command to perform compilation is very simple, execute_flow-compile. Intel FPGA recommends using execute_flow command instead of separate calls to Quartus_syn, Quartus_fit, Quartus_asm, etc. This example first uses the load_package command to load the flow package because this package is not loaded automatically. The project open command opens the project fir_filter with revision named filtref. Then, the execute_flow-compile command compiles the project. Finally, the project close command closes the project. You could have easily added the execute flow-compile to the previous example, which would have created the project, made assignments, and compiled it all in one script. In your script, if you'd like to compile or recompile your project from a clean start, you'll need to perform a project clean. Cleaning a project removes all Intel Quartus Prime software compiler-generated outputs for a specific revision or multiple revisions within a project. Binary database files, report files, and programming files will be removed while source files and setting files are not. Let's look at 3 examples. In the first example, a simple project clean will clean all revisions in a project. The second example will clean revision foo, while the third example cleans all revisions that start with foo. Now it's time for a pop quiz. Write a script that creates and compiles a project. You can do this using the scripts I've already covered as reference. Write a script to create the project and a script to compile the project. Pause this presentation while you work. When you're ready, resume the presentation and I'll go over the answer. Here's the answer to the pop quiz. This is a script that combines project creation with project compilation. First, the load_package flow command loads the flow package that includes the execute_flow command. The commands from project_new to set_location_assignment are from the project creating script. They create the project and sets it up with the assignments. Then, the execute_flow command compiles the design. The execute_flow command automatically writes assignments to the QSF, so there's no need to export assignments. Lastly, the project_close command closes the project after it's been compiled. After compiling the design, you'll want to get information from the compilation report. I'll talk about how to access report data next. The report package includes commands to access the Intel Quartus Prime report tables and data in those report tables and create custom reports. The report package is not loaded by default in most Intel Quartus Prime software executables, so don't forget to use the load_package report command. The commands listed here are a subset of the commands in the report package. Some commonly used commands used for report management are load report, unload report, and create report panel. To gather information on the reports, use the get report panel names, get number of rows or column commands. Most importantly, to access report data, use the get report panel row and get report panel data commands. I'll go over some of these in detail in the upcoming slides. First, I'll talk about the Intel Quartus Prime software report structure. Before using the report package in Tcl, it's important to know how compilation reports are set up in Quartus. This picture shows the compilation report window in the Intel Quartus Prime software GUI. A report is a hierarchical arrangement of folders containing report panels. The report hierarchy is shown on the left side of the window. At the top level, there are a number of report panels starting with the flow summary. Then there are folders depending on which modules have been compiled so far. In this example, we've ran synthesis, fitter, assembler, and timing analyzer, so each module would have its own folder. Each of those folders contain a number of report panels. Here, on the right-hand side, we're showing the Fmax summary report in the slow model subfolder of the timing analyzer folder. Commands to access the report panel data requires you to specify the full report panel name. The full report panel name is the complete hierarchical path to the report panel, including the names of the folder it's in. Hierarchical paths use 2 vertical bar characters to indicate each level of folder hierarchy. For example, a panel inside a folder would be identified by the name of the folder followed by 2 vertical bars, followed by the name of the panel. Nested folders are named with the same method, with each level of folder followed by 2 vertical bars. As an example, the highlighted panel in the hierarchy list, the Fmax summary report, has a full hierarchical name. Timing analyzer, 2 vertical bars, slow 1100 millivolts 85C, model, 2 vertical bars, slow 1100 millivolts 85C model Fmax summary. The first level reports have no double vertical bars. These include panels such as flow summary. Here's a quick description of report panel structure. Report panels are tabular, consists of rows and columns. You can refer to rows and columns in a report panel by their index or by their name. The index starts at 0 and row 0 has the column headings. In this screen capture shot, the row 0 column headings are resource and usage. If your script loops through rows in a report panel, you can start on a row 1, there's a Tcl command that returns the number of rows in the report, and your loop continues while the index is less than the number of rows. Here's an example on how you can access data in a report panel. You could refer to rows and columns by name or by numerical index. This slide identifies column 1, which also has the name setting. It also identifies row 2, which also has the name use smart compilation. You can use the get report panel data command to get the value in a specific cell. In the example here, I use the get report panel data -name followed by the full hierarchical path of the fitter settings report followed by the row and column names. This command should return on. You can access by row and column indices as well. In the second example here, I'm using get report panel row command to return the entire row of the report. I'm giving it the argument of -row2, which will return the entire row starting at use smart compilation. Now we'll look at a full example that uses the commands in the report package to print the worst case slack in a design. We will look at the multi-corner timing analysis summary report panel to accomplish this. In this panel, the worst case slack row will contain the numbers for worst case slack for setup, hold, recovery, removal, and minimum pulse width analysis, and we'll just print these out to the console. Here's the script that will accomplish this. The first 3 lines of this script loads the report package so we could use report commands, opens the project, and loads the project report. Then, we set the multi-corner timing analysis summary report panel name to the variable panel name. We then find out the number of columns in this panel by using the get number of columns command. The for loop in the script then loops through all the columns starting at column 1. In the body of the loop, the script gets the number for the worst case slack in nanoseconds and the corresponding type of slack. The puts command then prints out the worst case slack. Finally, we unload the report and close the project after we are done. If we run the script, our output should look like the screen capture at the bottom of the slide. In this case, all of our slack is positive, so we are passing timing. It's time for another pop quiz. This time, write code based on the previous example of parsing through the multi-corner timing analysis summary to print a message stating if a design fails or passes timing. As a hint, think about what kind of slack a design would have if it is failing. Please pause this presentation now if you want to code up your own example. Resume this presentation and I'll go over a solution. Here's the code that would print whether design passes timing or not. It's mostly the same as the example before. We're still loading the report package, opening the project, and loading the reports. With the first highlighted line of code, we create a new variable called failing and initialize it to false. We then loop through all the columns of the worst case slack row in the multi-corner timing analysis summary report as before, but this time we only get the slack number. With the second highlighted line of code, we check if the slack is less than 0. A negative slack indicates a failing design. If slack is less than 0, we set the variable failing to true and then promptly break out of the loop. Finally, in the third highlighted line of code, we check the variable failing to see whether the design passes or fails and then prints out the corresponding message. We've looked at how to parse through and extract information from compilation reports. Now, let's look at how to create time reports and gather detailed timing information for specific paths using Tcl and the Timing Analyzer command line executable. The timing-related Tcl packages provide a way to constrain and perform detailed timing analysis on your design. All of these packages are available only within Timing Analyzer Quartus_STA executable. Intel FPGA Timing Analyzer supports industry standard SDC timing constraints with the SDC package. The SDC_EXT package adds additional Intel FPGA extensions to the SDC standard to make constraining FPGA designs even easier. Finally, the STA package includes commands to create timing netlists, read SDC files, and run detailed reports. It is highly recommended that you properly constrain your designs using SDC design constraints. Constraints consist of commands in the SDC and SDC extension packages that describes the behavior of the circuit. For example, how fast you plan to run the clock, how much external delay there are for each of the data pins, and so forth. You should place all your constraints in the SDC file associated with the project so the Intel Quartus Prime software will be aware of them and will try to create a netlist that meets the constraints specified. When constraints are placed in the SDC file, Timing Analyzer can also read them with one command. If you're new to SDC and not familiar with SDC syntax, I highly recommend to use the Intel Quartus Prime software text editor to create your SDC file. There, you can use the Edit Insert Constraint menu to graphically enter SDC constraints. The Intel Quartus Prime software text editor also offers templates so you can insert a series of commands quickly. For more information on SDC constraints, please consult the Timing Analyzer online training or the Timing Analyzer user guide. After you've created SDC files for your design, you'll need to create a timing netlist and annotate it with SDC commands that you've saved in the SDC file before running timing reports. To do this, you'll need to run 3 Tcl commands from the STA Tcl package. The Create Timing Netlist command creates a netlist of your design with the desired delays. You could specify to use either post-synthesis netlist or a post-fit netlist depending on how far you are in the compilation cycle. You also have the option to specify the timing model to use and the speed grade of the device. Next, you'll run the read SDC command to read in the SDC file you've created. If you run this command with no file name argument, the command will read in all SDC files associated with your Intel Quartus Prime software project. Lastly, the update timing netlist command will annotate the timing netlist you've created earlier with the SDC constraints. This step will also generate warnings such as undefined clocks or combinatorial loops. After you've run these 3 commands, you're ready to run reports. Two commonly used commands to generate time reports are create timing summary and report timing. The create timing summary command generates a summary report with the worst case slack and endpoint total negative slack for every clock domain in the design. You have the option of creating a report for setup, hold, recovery, or removal analysis. You can also choose to output the results to a console standard out, which is the default, or output to a file, or to a panel in the Timing Analyzer GUI. You can use this command to quickly check if your design is passing timing. The report timing command is used to generate detailed reports on specific worst-case paths. You can also create reports for setup, hold recovery, or removal, but you have many more options to filtering your results by clock domain, by node name, and so forth. With the report timing command, you're able to see detailed path delay information for each node and interconnect that the specific path goes through. As an example here, the first create timing summary command here will create a hold time summary report and write it out to the file out.txt. In the second example, the report timing command creates a setup report with 100 worst case paths and will output the report to the console standard out, which is the default. On the following slide, I'll go over a Tcl script for the Quartus_STA command line executable to generate detailed reports on the failing paths in your design. It will find the failing set of paths using the slow corner timing models and find the failing hold paths using the fast models, since setup is more likely to fail with a slow model and hold is more likely to fail with a fast model. In the script, first, we open the project, create a timing netlist, and then read in the SDC constraints associated with the project. The for each in collection command from the Quartus miscellaneous package loops through data collections similar to the way for each command works in Tcl. Here, we get all the available operating conditions and assign them one at a time to the variable op. We then set the operating condition to op and update the timing netlist with that timing model. The if command then checks whether we're using the fast model. If so, we use the report timing command with the hold option to find failing paths. Failing paths are listed with the option less than slack 0, and the result of this report timing command is sent to top hold.txt. The else clause here is for the slow models. Here we will run report timing with the setup option. We have the same less than slack 0 to find only failing paths and append the results this time to top setup.txt. If there are failing paths, then the detailed path information would be written out to the corresponding text files. Lastly, we use project close to close the project. If you run the script on the previous slide, if there are failing paths in your design, your output file will look something like this. Here, you can see the report timing command returned one failing setup path with a slack of -7 nanoseconds, and the path is between yreg2 and myTDM mult entity. If you scroll down further, you will see detailed path information with delays for each interconnect and cell. Timing analysis, along with SDC and timing analyzer, is a large topic. To be able to fully utilize Tcl and the Tcl packages in the Intel Quartus Prime software to properly constrain your design, run detailed time reports, and then close timing, please consult the resources here. You can watch one of our online training, such as the ones on Timing Analyzer or constraining source synchronous interfaces. You may consult the Timing Analysis section of the Intel Quartus Prime Timing Analyzer user guide, or attend one of our 3 Timing Analysis full-day instructor-led trainings. It's time for a pop quiz on the Timing Reports section. What is the difference between report timing and the create timing summary commands? Please pause this presentation now if you need to think about it. The two commands both return timing information pertaining to your design. They have some similar options, such as the type of report to run and where to output the results. However, the report timing command returns information on the worst case paths along with associated slack and detailed delay information about the path. The create timing summary command will generate a summary report with worst case slack per clock domain. Now let's move on to miscellaneous Intel Quartus Prime software Tcl commands that can help you write your script in various ways. The miscellaneous package can help you in various ways. This package is loaded by default in every Intel Quartus Prime software command line executable. It has a number of useful commands. We've already seen the load package command that loads different packages. In this section, we're going to talk about the escape brackets, post message, for each in collection, and get collection size commands. Many Intel Quartus Prime software Tcl commands allow regular expressions in option arguments. However, the convention for bus naming in HDL is to use square brackets, which are special characters in Tcl regular expressions. Intel Quartus Prime software Tcl commands don't know whether you intend something with brackets to be a bus name or regular expression. You have to make sure that you escape square brackets for bus names correctly. Improperly escaping bus names is a common error. For example, address / square bracket 10 / square bracket can be interpreted as a regular expression matching address 0 or address 1. If you intend for this to match bit 10 of the address bus, square brackets must be escaped twice. This uses 3 backslashes. The first backslash escapes the second backslash, and the third escapes the square bracket. The miscellaneous package provides the escape brackets command for convenience. Use this command to do correct amount of escaping to prevent the bit indication from being interpreted as a regular expression. For example, here's a way to get all the location assignments for the wires in the bus name address. Set the address names to the pattern you want to match. Notice in the first line here, I'm not escaping the square bracket because the curly braces are used to group the string, which prevents command substitution. Then you could use the getAllInstanceAssignments command to get all location assignments applied to the bus address. Using the escape brackets command provides the correct level of escaping in this example. The post message command prints out messages formatted like Intel Quartus Prime software messages. You can specify the message type and text. Supported message types include info, warning, critical warning, and error. In the screenshot here, you can see the 4 messages I typed in the Intel Quartus Prime software Tcl console window and the way each is formatted in the system message window. These messages, however, do not support right-click functions such as help and locate like regular Intel Quartus Prime software messages. Some Intel Quartus Prime software Tcl commands, such as commands to get all assignments in your design, can return multiple sets of data. The sets of data are returned as collections. A collection is an Intel Quartus Prime software specific container. You can use commands in the miscellaneous package to handle packages. You can iterate over elements in a collection with the for each in collection command. It has the same syntax as the for each Tcl command. The get collection size command returns the number of elements in the collection. Here's an example that uses commands that manipulate collections to print details of all instance assignments in a project. The getAllInstanceAssignments command returns a collection of all the instance assignments in your project. First, we use the getCollectionSize command to find how many elements are in the collection and then prints it out to standard out. We then use the for each in collection command to iterate over all instance assignments. Each individual assignment is returned as a list that includes the section ID, the source name, the destination name, the name of the assignment, the value of the assignment. The command in the loop body here prints out each of these values. Now I'll talk about ways to access command line options passed to Intel Quartus Prime software Tcl scripts. The Intel Quartus Prime software supports the global Tcl variables argv, argc, and argv0. Command line arguments are also passed in using the Quartus args variable, so you have the option of using that as well if you wish. The table here shows the functionality of the global Tcl variables along with the equivalent when using the Quartus args variable. argv is equivalent to the Quartus args and contains the list of command line options. argc contains the number of arguments passed in and is equivalent to the length of the Quartus args array. Finally, argv0 is the name of the script run from the command line, or if no script is being run, for example when interpreter is invoked in shell mode, then argv0 is the name of the executable. You can also get this information by calling the info Tcl command with either script or name of executable as the argument. As we've seen in the previous slide, we can use the argv variable to access command line arguments in a list. However, a smarter way of processing command line arguments is to use the command line package. Rather than writing your own or hard coding indices of argv variable, Intel FPGA recommends using the command line package. This is part of the Tcl lib distribution included with the Intel Quartus Prime software. With this option, you'll be able to pass in arguments in the format of -option value. This allows you to pass in arguments in a flexible manner and makes your Tcl script more robust. As an example, using Quartus_sh executable, I'm going to pass the project name and an optional revision name into my Tcl script using the -project name -revision name format. Then, in the script, I'm going to use the command line package to parse the arguments. The code here opens a project, and if you specified a revision, it sets that revision to be the current revision of the project. If you don't specify a revision, it just opens the project with the default revision. The first command in the script here loads the required command line package. Next, the set options statement describes the way the command line package specifies options that will be passed to the script. In this case, there are two options, project and revision. The .arg following the project and revision specify that they each require an argument value associated with it. The empty double quotes indicates that there are no default values. After the set options command, the array set ops# command calls the get options command in the command line package to process any command line options, and it fills the ops# array with the provided options. The if statement determines whether or not the caller specified a revision by determining if the revision is an empty string. With no revision specified, the project open command will only open the project with the project name. If the caller does specify a revision name, the script opens the project with the specified revision. In the final section of this presentation, I'll describe ways you can use Tcl and run Tcl scripts in the Intel Quartus Prime software. There are a number of ways that you can use Tcl in the Intel Quartus Prime software. The most common is using a command line executable to run a Tcl script file. You can also use command line executables to run an interactive Tcl shell. Additionally, you can do direct execution of Tcl commands with a command line executable option. I'll talk about these in later slides. In the Intel Quartus Prime software GUI, you can open the Tcl console by choosing Tcl console from the utility windows list in the view menu. You can then execute Tcl commands, source Tcl scripts in the Intel Quartus Prime software GUI Tcl console. Some tools in Quartus also support Tcl. For example, the Timing Analyzer GUI includes an interactive Tcl console, and the system console used for in-system debugging also uses Tcl. Here are details on the 3 ways you can use Tcl with Intel Quartus Prime software command line executables. You can run script files, open an interactive Tcl shell, or perform direct Tcl command evaluations. You do this with any of the Intel Quartus Prime software command line executables that include Tcl support. A partial list of those executables are on the next slide. You could substitute any of the other Intel Quartus Prime software command line executable names in place of Quartus_shell in this example. To run a script file, at the command prompt, specify the name of the executable followed by the -t option, the name of the script, and any arguments you may have. To start an interactive Tcl shell, simply specify the -s option with any of the executables. Use the exit command to exit from the interactive Tcl shell. Finally, for direct Tcl command evaluation, use the -tcl eval option followed by the command to evaluate. As an example here, the command I want to evaluate directly is help-pkgflow. This is a partial list of command line executables that have Tcl interpreters built into them. The Quartus_shell executable supports general project management functionality. You can use it to make assignments, perform compilation and general reporting, and other shell functions. Other executables on this list perform specific functions. For example, Quartus_sta is used to generate timer report. The Quartus_cdb executable is used to perform back annotation, manipulate logic lock regions, and other compiler database related tasks. Quartus_sin, Quartus_fit, Quartus_ASM correspond to part of the regular Quartus compilation. Important to remember that different command line executables support different Tcl packages. Tcl commands are grouped in packages by function, and appropriate packages related to each command line executables are available for use in that executable. As an example, the Quartus_CDB, the executable, manages the compiler database and is related to logic lock, back annotation, the chip planner, and version-compatible database files. It doesn't perform, for example, timing analysis functions, so Tcl packages related to that are not available. To see a list of available and loaded packages for a specific executable, you can type help at the Tcl prompt of that executable. You can also see that information in the QHelp utility. When running Tcl scripts in Intel Quartus Prime software, it may be helpful to obtain information about the current executable running. The Quartus Array is a predefined global Tcl array that contains information about the current executable. You can access the content in the array with the $Quartus array key syntax, just like any other Tcl array. The table here lists some commonly accessed items. We've already seen in this presentation the use of the args element. You can also get the name of the executable, current project or revision open, available packages for the executable, bin path, and many other aspects of the current executable. If you already have a project open and have made all necessary settings, perhaps through the various GUI tools such as Pin Planner or Assignment Editor, you can automatically create a Tcl script that would recreate the project for you from scratch, containing all the necessary settings. This is particularly useful if you want to hand off your project to another engineer, or if you want to store the script in a repository. The Generate Tcl file for project option is located in the project menu of your Intel Quartus Prime software GUI. This is our final pop quiz. List 3 ways to use Tcl commands and scripts with the Intel Quartus Prime software. Pause this presentation now if you need some time to think about it. Here are some of the possible answers. You could have listed any of these. First, you could use the Tcl console in the Intel Quartus Prime software GUI. Next, you can run an interactive Tcl shell with a command line executable. Third, you could perform batch mode execution of a Tcl script with command line executables. Fourth, you could perform direct execution of Tcl commands with the executables. Lastly, though not covered in this presentation, you can run Tcl script using the Tcl Scripts GUI from the Intel Quartus Prime software tools menu. The Intel Quartus Prime software command executables include built-in help. You can access these with the help command in an interactive shell or evaluate the help command directly with the Tcl eval option. If you type the help command by itself, you will see a list of loaded and available packages. If you type help with the package name as an argument, you will see all the commands available in that package. Lastly, if you type help-command followed by the name of the command, or if you execute a command with a -h argument, you'll get help on that specific command. There are hundreds of commands in the Intel Quartus Prime software Tcl API. The QHelp utility is a great way of getting help on all of the command line executables and the Tcl packages that each executable loads. When you run Quartus_sh-QHelp, the QHelp utility opens in a Tcl/tk graphical browser. There, you'll find detailed information on all the options available for any of the command line executables and the Tcl packages that are supported in each executable. There are also examples you can base your scripts off of in the utility. With Platform Designer, there are some uses for Tcl as well. If you're not familiar with Platform Designer, that is our front-end system integration tool used to quickly build a system with custom and off-the-shelf components. Platform Designer will automatically generate the HDL for your system along with interconnect necessary to connect the components. All the Platform Designer compatible components have associated hw.tcl files that tells Platform Designer about the properties of that component. Usually, for a custom component, this Tcl file is automatically generated by the component editor. However, if you want, you can further customize your component by hand editing the Tcl file to include advanced capabilities such as HDL generation using instantiation parameters of the component. Please see our component interface Tcl reference for more information. System Console is our low-level hardware debug tool used to interact with the Platform Designer components through a USB, JTAG, or Ethernet connection. The entire tool is Tcl-based, so you can easily script communication with components, as well as to easily build custom GUI to display results. If you're interested in this, please see our System Console online training for more information. For additional references, you could refer to the Intel Quartus Prime Scripting User Guide chapter on Tcl scripting available at www.intel.com. If you need training on the basics of Tcl language, Intel FPGA offers the Introduction to Tcl Scripting free online training. And if you want to learn about advanced uses of command line executables, including integrating Quartus executables with makefiles, check out the Command Line Scripting online training. We've covered quite a bit in this presentation. Here's a summary of what we went through. We talked about using Tcl Quartus Prime software, Tcl API, to perform common tasks, including project creation, project compilation, accessing reports, and running timing analysis. We went through some particularly useful miscellaneous Tcl commands supported by Quartus. We talked about accessing command line arguments, and finally, we talked about using Tcl with the Intel Quartus Prime software executables. This slide represents a flow diagram of the courses that we have available and the follow-on courses that you can expect to take when you've completed a course. If you require technical support on your Intel FPGA solution, please feel free to make use of the support options shown on this slide. One last thing. When you registered for this training, a link was sent to you in your confirmation email that links to a short survey online. Please complete this survey to let us know what you think of this course and if you can think of ways in which it can be improved. Thank you.